This content area on Trailblazer 1 is called Aerodynamics. Now, aero means fluid, which could be air or water. So we're going to learn how everyday objects interact with those fluids. So our first exhibit in every content area is the one that's closest to the Trailblazer door. That way all the kiddos can move along in the Trailblazer in an organized fashion. So the first one is our Bernoulli's principal air cannon. So when I turn it on, you're gonna see this ball do something really cool. We're gonna have a column of fast-moving air because it's gonna have to speed up to go around the surface of this ball. And actually, fast air is weaker than slow air. So all of the slow air here that's piling down from the atmosphere and inside the Trailblazer is gonna hold it in really tight, and we can actually manipulate this column of weak air. So let's watch. I'm gonna turn it on with this light switch. And this is pretty cool on its own, but let's manipulate it a little bit. So we have that column of fast air that's weak and our slow air that's strong. Using our handy script right here, we can manipulate it. So I have the kids hold it here, press it down really flat, and we're directing that column of weak air and it's staying suspended in there, and that strong air is kind of holding it up and supporting it. So I like to let them test to see how far it can go, so let's try it again. And to round it out with a STEM career, airplane pilots actually use Bernoulli's principle when they're trying to figure out how does the airplane stay up. So airplane pilots actually make about $140,000 a year. So our next exhibit is called turbulence. So we're going to talk about what turbulence is. So whenever airflow hits and it gets kind of wobbly, that's turbulence, but let's see what that looks like. So we have these two tablets down here. There's some instructions, so if you forget what to do, they're all written right here. So I'm going to click on a wind tunnel app that's got some yellow and red stripes. And when that opens up, I'm going to hit interact in the top right corner and then draw wall. So what that's going to allow us to do is draw shapes. We have some examples on a form just right here, but the kids can come up and kind of create any shape they want. So I like to think of it as cars. So when designers are actually building cars, they like to test out their vehicles in a wind tunnel. So let's draw a big boxy Jeep or something. And we can see the patterns of air move around, and every time we have kind of these wibble wobbles, that means there's turbulence and the airflow is not as smooth as it could be. Smoother shapes reduce turbulence. For a smoother and safer ride, engineers use rounded shapes to design planes, trucks, cars, and even rockets. One example of a STEM career that uses this exact tool is an automotive engineer. They design all of the cars that we're driving, and they make about $115,000 a year. So our next exhibit is called Bridge versus Wind, and it's really just this monitor right up here, but we're going to talk about it in a little bit more detail. So what this is the Tacoma Bridge, which as you can see it right now, it's really wibbly and wobbly. What happened is that these parts of the bridge on this side when the engineers were building it, they didn't account for the wind that was going to blow through the valley. And what it is, it's causing it to rock, it's that turbulence. And eventually, the resonant frequency caused it to break. And you could ask kids at the very beginning, do you think that wind could break steel? And some of them might guess yes, but for the most part, they will say no. And so then I like to hand everybody a paper clip. There's a box of them over here. I tell them, I have to have this paper clip back at the end. So then their job is to sit and bend the paper clip back and forth while we're watching it. And don't take up too much time because it's a short station, but still, back and forth, and eventually somebody's gonna break it. And that's when you can say, see, lots of repetitive movement over time can break that steel, just like that happened in the Tacoma Bridge. Now, civil engineers, the people who build our bridges now, definitely take into account aerodynamics. This is a famous example, it happened long ago, but we do take into account, even when we're building skyscrapers or anything that's gonna be big and tall and have a lot of wind impacted. So civil engineers actually make about $98,000 a year. So the last exhibit in the aerodynamics content area is our wind tunnel. So we have these vertical columns of wind. When we turn them on here, you're gonna hear those fans blow. So what we're gonna learn is which shape is more aerodynamic. So remember, that's when the air flows around the shape smoother. So we want planes and rockets and things like that to be more aerodynamic. So we need to study those shapes. So we have a collection of little foam shapes right in this bucket back here. So I have them grab a shape and then look at it from every angle. So what's the difference between these two shapes? So we can see there's a little bit more surface area, so let's see how that's affected. So we're gonna turn it on and release them at the same time. All right, ready? 1, 2, 3. So what we saw here is that the air was moving so smoothly around this rounded shape that it actually stayed suspended right here. And the air pushed on this side, and so it moved up. So we can play with a bunch of these different shapes. You can have races, you can see what moves faster, and that way they can just study what happens in that wind tunnel. So somebody who uses a similar wind tunnel are aerospace engineers. They build the actual rockets that go up into space, and an aerospace engineer is gonna make about $105,000 a year.